All right, pre-calc students, we're going to try a little video mini lesson here. So in lesson 8, our last lesson in the second unit on trigonometry and their graphs, we're going to be solving some problems using trigonometry. So any technique or anything we've learned about the trig functions is all fair game here, and we're going to put it together to solve some word problems, which are real life kind of problems. So first of all, on this first page of notes, it talks about the ideas of angles of elevation and angles of depression. Basically, if you take a look at the diagrams here, an angle of elevation would be if I am looking out at the horizon, then I look up. The angle that I've created by looking up from the horizon would be an angle of elevation. Okay, so my line of sight is raising from the horizon, that's angle of elevation. If I'm the guy standing at the top of the Grand Canyon, as this figure is supposed to depict, he's looking out at the horizon and he looks down. So the angle that's created by looking down from the horizon to the line of sight would be an angle of depression. Now the neat thing about these two things is that if I think about this, here's a pair of parallel lines. And then this line of sight would be a transversal. And if I cut a transversal into a pair of parallel lines, the alternate interior angles are equal. So that means, if I can get a pen tool here, that means that this angle right here, the angle of depression, is the same as the angle of elevation if I think about looking from the bottom up. Okay, same goes over here. If I draw, here's the horizon there, there's the horizon there. Well, for the family, this is their angle of elevation as they look up at George Washington. But as George Washington looks down at them, he's got an angle of depression, and those angles are equal to each other because they're alternate interior angles. The other thing to note is that if I'm George Washington looking down, I've got this angle of depression, and then if I add in the rest of this angle, those would add up to 90 degrees, so those would be complementary angles. We'll use that idea in our first example here. So, moving on, the angle of depression of a buoy from the top of the Barnegat Bay Lighthouse, 130 feet above the water, or above the surface of the water, is 6 degrees. Find the distance x from the base of the lighthouse to the buoy. So we're going to find this distance right here, and we know the height, and we know an angle of depression, it says. So that's looking from the top of the lighthouse, looking out at the horizon and looking down, there's 6 degrees. So I need to figure out what this side is here. There's a couple ways I could go about doing this. One would be to label this angle. And again, because it's an alternate interior angle with that one, it's going to be 6 degrees. Okay. So keeping that in mind, I see that I have the opposite side compared to that angle, and I'm looking for the adjacent side compared to that angle. The opposite and adjacent go together when I'm working with the tangent function. So what I'm going to do is I'm going to write a trig equation where the tangent of 6 degrees, make sure you're working with degrees here, is equal to the opposite side length, 130, divided by the adjacent side length, which happens to be x. Okay, and then I'm going to solve that equation. I'll show you how in just a second. Now, another option here would be to use this angle, which would be complementary with the 6 degree angle of depression. So this angle up here in the top corner would be 84 degrees because those two angles, the red and the green ones, have to add up to 90 degrees. Okay. So in regards to this angle, 130 is the adjacent side, and now I'm looking for the opposite side. So it's still tangent, but look at how this goes a little bit differently. So now the tangent of 84 degrees is equal to the opposite side, which is x, over the adjacent side, which is that 130. So both of these equations are correct, and it's a matter of solving for x. And as we do that, we're going to get the same thing in both. I'm going to solve the red one first because that's actually a little bit easier. When the x is on the top, it's as simple as multiplying it by the bottom on both sides, and that'll be good to go. So we would type into our calculator 130 times the tangent of 84 degrees, and we'd have x. If I was doing it this way where x was on the bottom, I'd actually have to do 2 steps. So I would have to multiply by x on both sides to remove it from the denominator. And then I'd have to divide by the tangent of 6 degrees. Okay. Now as you get good at these, so I'm dividing both these by tangent of 6, as you get good at this, you'll just kind of recognize that those things will switch places. So essentially this is what we've got. We've got x is equal to 130 divided by the tangent of 6. So if you check out the blue equation, it was tangent 6, x here. Well, now it's x here, tangent 6 here. They just kind of flip-flop. Again, a little trick as you get better at this stuff, knowing how it's going to work out. But in either case, I've got answers that I can type into my calculator, so we're going to do that next. So make sure we're in degree mode. Okay, so I have set the mode already. I'm in degree mode. That's good. So I quit, go back out to my main screen, and I'm going to type in the 130 times tangent 84 first. So 130 times the tangent of 84 degrees. Hit enter. Here's my number. So 1,236.9. I believe it's feet that we're working with. Now, if I do it the other way, and I take 130 divided by the tangent of 6, let's see what we get. 130 divided by the tangent of 6. Close the parentheses, and we get the exact same number. Okay, so same number should work out. Either way, this would be our answer, the 1,236.9-ish. Cross that off. So there's our answer to the first one. Either direction is fine, just whatever works best for you in your brain to make that work. Trying another one. So here we've got, from the top of the 100-foot tall Altgelt Hall, a man observes a car moving toward the building. So imagine there's, some guy just sort of hanging out up here on top of the building. Okay, yay. And he's seeing this car. The angle of depression changes from 22 degrees initially. Is red to the red car. Okay, and then as the car moves, it's going to be then at an angle of depression of 46 degrees. So now he's looking down at the car and it's a little bit closer. Okay. Alternate interior angle, so we can label this as being 22 right there, and we can label this as being 46 right there, and it is in your diagram. 100-foot tall building, so I see that labeled. Okay. And the question says, if the angle of depression changes, how far does the car travel? So how far does the car travel would be from here to there, which is labeled in your diagram as being x feet. Okay. So I still have this d. The d expression would be the distance that the car is from the building when it's close, at that 46-degree angle. I'm going to add one more thing here. I'm going to, because we're essentially going to use a couple of triangles here. So there's two triangles I see. One of them would be this triangle, that's the building, and the short distance in my line of sight. Okay. The other triangle that I notice here is the building, again, and the line of sight to the other car, and this length all the way to the building. And that length all the way to the building, I'm going to label underneath as being distance A. And I use A just because it's A for all in my mind. That's how that works. Okay, so all of the distance from there to there. What I'm really concerned with, though, remember, is I'm trying to find this distance from car to car, x. So I'm going to write myself a little equation here that says x is equal to all of the distance minus d. All of the distance minus some of the distance. So all the distance from the red car to the building minus the distance from the blue car to the building. Okay, that's x, the distance that the car has traveled. So finding x is a little bit tricky at first, but I'm going to use tangent here a couple different times. So first thing I'm going to write out is in regards to this purple triangle. Okay, so in regards to the purple triangle, I know that I'm working with 22 degrees. So it's the tangent of 22 degrees, and that's equal to the opposite side, which is 100 feet, divided by the adjacent side, which is the A for all, that whole distance from the red car to the building. Okay, now D, I'll do that in yellow. May not show up. No, it doesn't look real great. So we'll go orange. That'll look a little better. So tangent of 46 degrees is equal to the opposite side, which is, again, still 100, divided by the adjacent side, which is D, that distance from here to there. So we'll make it orange so it matches up with the writing. So orange triangle. Okay. So I'm going to solve for A, I'm going to solve for D, and then use those to find out what x is. So to find A, remember a little quick switch. If it's out of the bottom, I'm going to move it here and divide. So I'm going to take 100 divided by the tangent of 22. Okay. And I'll actually write that. So A is equal to 100 divided by the tangent of 22. So I'm writing it because I'm going to show you, I'm going to type the whole thing in my calculator at once just to show you what that looks like. And then for the orange one, I've got D is equal to 100 divided by the tangent of 46. All right, takes a while to write that in. Okay, good. So remember that A minus D is going to give me X. Okay, so we keep that in mind. We're going to take on our calculators, we'll put parentheses around 100 divided by the tangent of 22, close parentheses, minus parentheses. That next expression was 100 divided by tangent of 46. So 100 divided by the tangent of 46. Okay? And close parentheses, close parentheses. So what this is doing, it's finding both A and D and taking A minus D, which again is supposed to give us X. Okay, it's supposed to give us this expression I see over here. So when I hit enter, ta-da, I get 150.9. We'll just round it that, 150.9. So that would be my answer for X. Oops, I want that again. So that was taking this expression for D and subtracting it from this expression for A, letting my calculator do all that work for me, which gave me, again, a final answer of 150.9 feet is the label again. So that's what X is equal to, the distance that the car has traveled as that angle of depression has traveled. So we're going to cut the video there and then pick up in another one with the other examples.